All right, I wanted to show you a little bit what it looks like, after the surface is clean. Really, really important. Do not use anything abrasive in this. You need to have this nice, smooth, polished surface in order to have the maximum amount of heat transfer. Same thing goes with the block. Extra care when you're handling this. Make sure you don't ding it or you don't, put any kind of gouges in this surface at all, because if there's not intimate contact between the Peltier devices and the surfaces of the aluminum, you're not going to get good heat transfer and the thing's not going to work properly. No amount of heat sink compound, thermal compound is going to help your problem there. So pay special attention to these surfaces and keeping them nice and polished throughout all your handling and everything like that, okay? Because you're going to be asked for trouble, okay? So super careful the way you handle all of it, all right? So I'm taking this off to clean everything up, and I just want to show you guys something. So 4 screws on the back, and you got to take the 2 screws out from that area there, and then this whole thing comes right out, okay? Now, remember I told you that there's an air intake, on the bottom side of the heat exchanger there. Look at that. That's all clogged up. That's to protect the screen, to prevent crap from getting into the intake of where the air comes in for the combustion air for the nozzle. That's going to cause you a problem if your combustion process can't get enough air to do its job. So just keep that in mind. This all comes apart pretty easily, but we're just taking it all apart to clean it, because this is, I don't know how many years, 5, 6, 7 years worth of crap. And you can't see that from inside. You can't see that from the bottom. When you look up underneath, all you see is the bottom side of the combustion chamber or the nozzle holder. But this whole thing just comes right out. And you got to pull the screen off. It's got a clip on there. And then we clean it up. Simple. One thing you will need to realize, just don't go pulling it out. See this little tab here? You got to bend that sucker straight so that this thing will slide right out, okay? All right, so what I've done is I've got everything kind of cleaned up here. You can see what the inside of the chamber looks like. Again, your nozzle's inside this chamber, and the flame is underneath here. All the heat goes through. And then there's this, the little, I guess you want to call it diffuser, heat diffuser, whatever. I cleaned all this up. Be careful handling this, because all these plates will slide out this direction. You can see that they're held in the other side, okay? So, if you're going to whack it out or whatever, I use compressed air to blow all that out. But, you might... You shouldn't take it apart. Just try to clean it up and make sure you could see right through it, okay? And then this is the plate I was telling you that goes on the bottom of it. It's inside there to allow the flame and the heat go right through. There's a retaining clip there. I did want to make a comment on the screw holes. Most of these screws are 4 millimeter with a 0.7 pitch. Okay, so that's what we're dealing with there. So you want to tap, a bottoming tap, and a die to basically run through some of these holes. If you don't need to do it, don't bother. But if, like in my case, this was the one that was very tough, I decided to run a tap into there and make sure I also cleaned up the screw. By running it through the die. You don't want to put stuff back in there that has remnants of aluminum corrosion on it, because it's just going to bugger up the threads, and you may end up causing more problems than you want to deal with. Again, drilling out broken screws, that kind of thing. So again, tap and die are 4 millimeter 0.7 pitch. Okay. A lot of tap and die, metric tap and die sets will have this in there. I just happen to have a whole pile of them. So the next step really, before we start putting this back together again, is to make the gaskets. And like I mentioned before, we're going to take the material, put it on the bench here, flip this over, and basically trace around the outline to get the outline of the shape. All right, and then it's a solid piece, but in the middle of it, you're going to have to put a slot in it to be able to put this tab through, so that this whole surface here that you see is going to be covered by the white ceramic gasket material. Okay, so we need to make a gasket for this. We need to make a gasket for this guy, which is actually no, we don't need to make a gasket for that. We need to make a gasket for this guy, which has this plate. So you use this plate, just trace out the outline of this, make sure you cut little notches in for the screws, and yeah, it's pretty straightforward. And then the two gaskets for this, which, you know, you could probably, if you have enough of it left, you could probably make, you know, one out of an old broken one. But that's what it's going to look like when I finish with it. I'm going to make two of these. They're both identical on both sides. And you notice they have a thick side and then three thin sides. So that's the case with the upper and lower. And it pretty much follows the same shape as this, as you can see. All right, pretty straightforward. Okay, here's the gasket material. I believe it's 1/16 thick. It's a very high temperature. I think it's like maybe 1900 degrees Fahrenheit. It's like a thermal blanket. So what I did is just traced it out. Again, this stuff is, you know, it's kind of fragile. You got to be careful with it, but, you know, nice sharp knife, trace it out, cut it out, and then this thing will just fit right there. And then this guy goes on top of this, and then this little one on the end goes on the end of the, actually goes on this guy here. So when all this goes together, all this will all be gasketed. Now I got to do the red ones here, and here's the gasket material I've got here. This is not a tremendously high temperature. You don't need a high temperature for this, but it should be a decent gasket material. I think it's probably a little less than a 1/16 of an inch. I'll tell you in a minute here what that's going to be. As far as you probably want to be about 40 thousandths thick on your gasket for the hard gasket. I think that's what this material is 40 thousandths. So again, a sharp knife. I'm going to make 2 copies of this guy, and we should be good. Okay, well, I also want to show you guys what it looks like when you put these two pieces together. See the gaskets right underneath there, fits nicely in there. Not blocking any openings, so on and so forth. This is what the gasket looks like in here. And then this little guy will basically go over like this. That's the way it'll look. So those are the 3 gaskets there. Now we're going to put this thing together here. So you're going to take your bottom plate. Before I go further, you know, Dremel wire brush head, stainless wire brush head. This is the best thing to clean all this out, all this stuff. You know, I've got a wire wheel on my bench press here, but certainly the Dremel comes into really handy cleaning all this out very nicely, very quickly. And you really should get everything really clean as much as you can get it. Again, you're not damaging the surfaces of the metal. You got to be very careful with that bottom side. You're not going to take a wire brush to that, okay? You got to be able to see the reflection, and that tells you everything nice and smooth so we can get good heat transfer. But so I'm going to put this all back together kind of the way it came apart. This bottom plate goes on, and then your little block will go there. Remember, I sketched an arrow. See the little V there? It goes straight up. And put it all together, and we'll see where it goes. All right, so I got the fusion in there with the arrow pointing up, and that has the the tabs that hold all the stack of plates that are in there. You got this arch spring in there that's keeps everything from falling out the other way. But you got to understand that. So the flame is in here. These kind of like diffuse the flame, and the heat starts to travel up through here, and up here on the side hole here, that's where your thermopile for your valve is sitting. So it's sitting right above all that, getting nice and hot. And then the hole that's over here is where your igniter is. And the igniter lights, I think, goes right down to this point here, and it's right up against or very close to the diffuser. And that will have an arc jumping across, and the whole chamber is filled with gas and will light right up, and then you'll have a flame coming out of here. So I hope I've explained this to you guys pretty straightforward. It's pretty basic when you get into it, but obviously the first time you dive into something like one of these things, it gets a little intimidating. All right, guys, this is what you get when you cut the two gaskets out. They all fit on this, and they're again identical. You got to make sure you put the right width side on this, because these sides are thinner than the one. So you got three sides, and then you got a thicker side. Same thing for the top and bottom. So now that we've got all the gaskets cut, now we start putting things back together. We're going to start with putting this whole thing back together at the bottom part, and then we'll turn it around. All right, so we're putting screen back on, and this fits on a certain way, but it goes this way, I believe. And there's a tab on the inside. You got to be very careful with this tab. We don't want to break it, because we need to bend it over the edge down here when we insert this thing back. So this thing just drops in like so. Yep. We got to bend that back just a little bit. Straighten it out just a little bit. Again, we don't want to break it. Don't want to break it. So you just want to make sure that this screen is over this thing, because if it's not, we're going to have problems getting this thing to seal up. We don't want to have any bugs able to get into this area here, because if they get in here, you're going to have problems getting this thing to light up. So maybe we try it this way instead, and then we try inserting it this way. Yeah, that works a little bit better. All right, there we go. So we'll bend that down once we get the main thing in here. So then we have the gasket. What are we going to do? We're going to do this on. We'll do this on here. This one lays over the outside here, like so. And then we're going to put this guy like so. And it's just getting everything lined up so it all sits in there nice. Easier said than done. There we go. All right, so that's good there, and we gotta get a screw on the other side over here. Excuse me for a second. Again, non-magnetic screws, but as long as we get one started in here, we should be all right. There we go. All right, so there are 4 screws. It's 4 millimeters. you know what? That's good. That's good. Grab another one. So as we put this thing together, we just want to make sure you're not over torquing anything. You don't want to torque the living crap out of these screws, especially when they're connected. They're connecting plastic to this thing, because you will suck the screw right through the plastic. So we're just snugging them up pretty nice. Don't snug them up right all at once, but just do it after you get it all hooked together like it is. All right, and then we have the 2 screws on the side to hold the intake. You see here. So we're going to take this guy. If I can just hold it right. Yeah. And you're going to see registration marks on the actual housing here. So before you tighten it up, push it up to where it should be, and then you should get close to your alignment to where it's going to go. But you can see we put the cover back on. Again, snug those up nice. All right, so that's pretty straightforward right there. Now we get the housing mounted back on. Again, super careful with this spot right here. We want to make sure that stays nice. Might as well throw on the gasket just to keep it out of the way. On the top side where the fan goes. And then I will be able to slide in this guy. Actually, we have to pull that off because this thing has to slide in to here, like so. Okay, that's where that's going to go, and then this thing will slide on top of it. Let's get that out of the way for now because we got to put the combustion chamber on, so we're not going to do it that way. We'll just leave that on. Here's the combustion chamber all put back together. See how nice the gasket is in there. Everything's clean. No issues with this. We don't have to polish that or anything. So the next step is going to be prepping this. One of the things I want to talk about is the heatsink compound. This is the stuff that I'm using. I've got, again, Amazon Easy Cargo Thermal Grease ES 410. Again, I got it on Amazon. Big tube. I'll never use this much. I don't do that much of this, but hey, maybe if I get into a business, doing these things, or you do, you'll use a lot more of this. The way you do this, so it comes with a little spatula, and we're gonna basically spread nice and easy on this surface, as thin of a layer as possible. You don't want to have it so it's built up or anything, because you just want it oozing out everywhere. Okay, when everything is compressed back together. So it's a little bit of a kind of like by feel kind of thing, but you're putting on a thin layer. And what this grease does is it makes sure you have full contact and allows the heat and the cold to transition across the various interfaces. Okay, it's kind of like computers, computer chips use this kind of grease on the heat sinks to make sure you're pulling out as much heat out of the chip as possible, because any kind of difference in materials and surfaces that are touching one another, you're going to have areas where if you look at microscopically, you might have an area where flatness isn't as good, or there's a bit of a surface finish issue that is not giving you as good a contact with the other surface as possible. So the grease pretty much helps you kind of overcome those little things and get the maximum amount of heat and cold contact thermal transmission through all these surfaces. So that's the purpose of the grease. It is messy. It's kind of like if you're working with silicone, but it doesn't dry. This stuff just stays like a putty. It's thicker than toothpaste, but it's pretty tenacious. So yeah, fun stuff. And what I did here is I marked out the outline of where these chips modules will sit. So you want to spread within that area. There's some excess area around the outside. You don't want to coat all of that because stuff just gets stuck to it. It's not doing anything and it'll just make a mess. So try to keep, the compound in there. And then when we do the back side, you can kind of see the outline of the chips, it's just going to be the same way. You know, we're not going to do this whole side right here because it's got the outline, and again, you want to keep in the same area. All right, so I spread all the compound, you know, just use a spatula. I got it on this side as well. Looks pretty good. Now we gotta carefully put the modules back in. So again, what do we say? Printed side down. They're kind of, the wires kind of hold everything. Now you don't want to like let these things flop around or slide around once you place them. So get them pretty close before you drop them down into the compound. And hopefully this is not going to turn into a disaster. Oh, sliding around a little bit. So we get them all put in there. And once we drop on the top part, it should be a little easier to control. So I'm going to drop on this guy. And again, this goes in the hole. And then, yeah. Oh, shit. I don't know what to do. All right, so we'll take two. I had to take the combustion housing off because I got to really slide this thing on, and you can put that on afterwards, so no big deal. So you want to make sure you have the other post ready to go. Get everything fairly lined up as much as you can, and then grab your combustion chamber. And at the hole, actually, I'm going to put this guy in first. Let me do that. Make sure that's all together. And where am I here? That's not it. That's it. There we go. So you get the two posts in. Snug it up. And make sure this one's snug too. That's good. Okay. And then ready to go. And just give these a little shove. Hey, you know, as long as they are, you know, nice and flush and flat, you should be okay. So you just lower this down, just like that. Okay. Remember, here we go with the washers. Very important. So we do a single washer below, and then there are 5 washers on either side. You want to alternate the washer direction. So this one's curved up and curved down. This way. That's 2. Curve up and then curve down. Okay, and then curve up. So should be 5 on each side. 1, 2, 3, 4. 4, 5. And then it gets 2 washers up top. 1, 2, and then the nut. That. And then we start off with the other ones. Do curved. And alternate 3, 4, 5. And then 2 washers. Okay. And the nut. Just like that. All right. So before we tighten everything up, make sure everything is centered. So I could see on this side that the modules are just sticking out just a hair. You can make sure everything is underneath. There's nothing sliding out or protruding past. Everything, the whole surface of the module has to be under aluminum, touching aluminum. Okay, very, very important. Okay, so we got all that stacked up. Everything looks good. Looks fairly straight. So now what we're going to do is we're going to start tightening everything down. And you're going to have a little compound oozing out. That's okay. A little turn there, a little turn here, and just pay attention to the way these things go because you don't want it to lock up. And these are about just tight enough like that. You're not going to get it much tighter than that. So that's good. It's all good. Now we've got to put the combustion chamber back on, and so it's a balancing act. Remember right before I told you about the tab here. You don't want to make sure. So hold that in like so, and then we can put this guy in like so. Sometimes it just doesn't want to go in there. But let's bend this thing back. Let's bend this thing over. Like that. So that hooks it in there, so it's not going to slide back out. Then we take this guy and insert it like so. All right. Getting there. Well, again, you want to make sure that cover is sitting over there right at the right time. It's not going to go easy. All right. All right, well, it took me a little fiddling, and I don't want to waste time on the video, but you got to make sure that you're kind of holding that screen in there while you're putting this thing in. The alignment is, again, you're trying to balance like 3 or 4 things at once here. So just take your time, get it all back together, and it's all good. So now that we got the main engine there put together, now we can start adding more parts back. And why don't we do the top here, fan. And make sure we got this the right direction here. This way. And just make sure when you cut the holes, everything lines up, so you don't want to block any airflow. That's like a main thing there. But just be super careful with the gasket, because it will slide out if you're not careful. And let's see if we can get this thing in here. Left-handed. And make sure it's straight. You don't want to block anything. So there we go. Nice and straight. It's kind of a little bit of a flimsy design in general, but it is what it is. And don't over crank this or anything like that. Then we're going to do the gasket. Again, we're going to make sure that our right thick side is the way it should be. And remember what I said about the fan when we took it off. We want to make sure that the fan is near the plug for the fan here. So we're just going to slide on like so. Okay. And we got to put a little washer on each stud. A washer, and there's going to be a nut, of course. Again, we are not cranking these down either. These are not crankable sizes. Talking about 4 millimeter. It's like basically the size of like an 832 screw, which can only handle a certain amount of torque at the end of the day. That's why I don't use ratchet. I use a nut driver. And just alternate sides. You're just holding the fan in place. You're not sealing anything per se. It's not like there's any issue. Okay, so that's good. Then we plug the sucker back in. Again, it only goes in one way. Click, just like that. All right, so that's there. And the next thing we got to put back, let's put the lighter, the igniter back in. Before we do that, let's just clean it with a little brake clean and take that, all that stuff is off, and we're going to be putting it right there. So this is going to go up underneath like so. And remember what I said about the ground wire, it's going to go underneath the bracket. So kind of get it all placed in like that. And we're going to take our screw for that. Where are you? There we go. And, this is a pain in the ass, but you got to get it kind of the first start maybe. There we go. That's good. Like that. Make sure the I know on my other one, the this protective jacket over the cable. Actually, this whole thing gets pretty hot, about 170 degrees. I measured it. So you know, you don't want any wires kind of resting on any of this aluminum in this area. It's really gets really warm. All right. So the next thing we're going to do is let's put the nozzle in. Oh, so what I did with the nozzle is I basically just take some brake clean and blow it through here. You're going to see very fine stream of brake clean coming out the nozzle tip here. That's good. If it doesn't, you're going to have to, you know, work on this. I never seen really one of these clogged up or heard of one of them clog up. I know on the mosquito magnets, they use a completely, almost like an oil, an oil nozzle for the gas. Believe it or not, it's a typical oil nozzle, similar looking oil nozzle, what you would find in a burner on a you know, on a home residential burner or commercial burner in general. So this is obviously a lot different than that. So you can see there's a screw where that goes in. Remember we talked about the screw. So that's going to be facing up in this case, and this just slides right in. And what you're going to do is you'll look down and make sure that the screw tip, or I mean, I'm sorry, the screw threads are aligned with the hole here. And that puts it out about flush. And then we're going to take that special screw that we talked about, the gold one. That's the one that is supposed to go into this guy. And I have this a little magnetized, so we can just drop it in here. And that's going to thread into the actual nozzle. It's a little bit past flush. So we just tighten that down again, not too crazy, because we want to be able to take it out next time. Make sure you take your silicone plug and you put that sucker back in. That keeps everything kind of sealed up. You might need a little screwdriver to pop that past in there. Okay, that's good. So you get the plug in there, get that. Talk about that valve in a little bit. So this guy, this one here, I want to talk about that in a minute. Let's get one more thing done here. Let's put the thermometer back on. I think we can do that now. So this is the thermometer. This is it's really, you're when you're lighting it, you're looking for it to go into the green, and then you can let go of the pilot portion of it. This little O-ring, make sure this is here. This helps seal the shaft against the housing. So we're just going to insert that like so. Then we're going to put, I don't know if I can do this with 2 hands, but I'll try. This guy, go here. All right, so you want to make sure this thing is pretty vertical because it has to line with a hole in the housing when you slide the housing over. So just make sure it's vertical, because it can go back and it can go side to side like this. So just make sure by eye it's pretty close to being perpendicular with the fan surface. This surface here, it's going to be pretty close. All right, so that's good. See that the O-ring is right down there, nice and easy. All right, so we're going to be flipping this around and getting into it a little bit more. We're going to get the control valve put back in, and I want to talk about the thermopile. Okay, let's talk about the thermopile and the control valve. These 2 items are probably the most important thing for this thing to work properly, consistently, aside from the combustion chamber, assuming gas is flowing and the nozzle isn't clogged, and the little sintered filter is not clogged. There should be no reason why gas should not be in the combustion chamber and lit. But this control valve is very important along with the thermopile. This is that thermal switch I was telling you, the overload switch. All it does is it basically, when everything is fine, there's a complete circuit between the wire coming out of the thermopile and the wire going back to the valve. When there's a fault, this thing opens, and again, it cuts the electricity to it. So let's take this apart. I've already loosened this already. Just use an open end wrench, hold the valve body, and then a 13mm will unscrew this end here. So you can unscrew this like so, and it's just a aluminum cap, and then this guy is your little coil. This is kind of a cute little thing, but it's a little coil inside this little arrangement here, and the end of the thermopile will actually touch this. This is insulated from the outside here. So, basically the 2 ends of the coil wire is, one's connected to the body, one's connected to the center pin. And like I mentioned before, when this has heat on the end of it, this generates an electric current. And when you push down the little red plunger there to light the unit, it's actually pushed inside the valve, pushing this guy away from a seat where this rubber donut or rubber gasket is sealing against, and that opens the gas to the valve, to the nozzle. Okay, when you let go after the thing's generating some heat and some electricity, this little guy will stay retracted because it's an electromagnet, and as long as the valve stays lit, this thing will stay open. As long as there's gas, and gas is coming in and keeping everything lit, this thing will stay open. The moment that you run out of gas or there's a fault, this thing will slam shut and everything will shut down. So it's just kind of like a safety valve, a safety feature as well, very important. But a lot of these valves, I know similar valves are used in like the deck heaters. They have different fittings above and below, and they even may have a knob that you push in to light, and then you could throttle the gas, but there's no throttling on this. It's either on or off. Okay, so trying to get this valve, a new valve, just to have on hand, it turned out to be a little bit harder to find this exact configuration. I get a funny feeling that this is only available from China directly and not in the States. This cap is just a cap. It comes right off there. So this is what you would get, the valve along with the little solenoid in there. And so what we want to do is what I found on Amazon, I believe is Amazon, is a new solenoid valve that works just fine. So that's the part number of the unit. Okay, and these fit right in here. So what I'm going to be doing is I'm going to keep one of these or a couple of these on stock. They're pretty cheap. They're like $8-10 bucks. I don't remember what the hell it was. I'm going to keep this on hand. I'm going to keep a couple of Sintered filters to be replacing. Here's one of those, the light body that's on the inside. I keep an extra one of those. That's what that looks like. Okay. Again, just Google it. And then also the Thermopile. This one's pretty close in length and everything that you need for this unit. It has the same diameter Thermopile. It's very similar, in shape to what you get. Okay. And the ends are pretty much identical, and it operates the same way. So, but it does come with factory terminated spade connectors, which we're going to be cutting off, and I'm going to be basically resoldering the wire to that. So you'll see. So we have to this basically will go right to where the switch is. So I'm going to be resoldering basically these to the new Thermopile. Pretty straightforward, but again, those are the parts. So we're going to throw in the new unit, which is here. You just make sure there's no debris in there. I use compressed air a lot, but I would not spray any brake cleaner or anything inside this valve when you drop this thing in. Just make sure there's nothing down in there. Use compressed air, your breath, whatever, and then this thing will just drop right in like you see, like that. Okay, and then we're going to take the cap and thread that right on and tighten it up. So I'm going to be, like I said, I'm going to be keeping a couple of these on hand, just because I've got 3 of these units, and certainly don't want to have to be waiting for weeks or whatever supply chain issues are going on anytime soon. So we don't over tighten this. This is brass, aluminum, and then this is brass. You can certainly over crank it if you're too much. But so now we got the solenoid change out there. Now we're just going to drop this thing back into the housing. We're going to use the nut and the washer underneath, and we're going to drop it down in. So let's see how that works. So you're going to have to compress the button just a little bit to get it past there. There is a negative shape of the nut molded into the housing, so you can only put it in one way. No big deal. And then put the nut in underneath there. Again, we're not over tightening the crap out of this. Just use your adjustable and crank it up. All right, so now we have that on. Now we want to get the line put back. So again, you got to be very careful with these things. Again, don't over tighten. Very, 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 very important. You don't want to over tighten any of this stuff, because you will have a leak, and once you have a leak, it's gonna be game over, because unless you can find, you're gonna have to find exactly the fittings and remake your own line. And if you have to get a new valve because you cracked it up, that might be a problem as well. So just take it easy. They don't, they're compression fittings. They're already been compressed once, so you don't need a whole lot of extra pressure to get everything nice and snug and sealed for the gas. This is not a high pressure scenario, okay? So, you know, you're not holding back, you know, a lot of pressure with this system. It's just, you want to make sure there's no, you know, easy leak for this thing to work. So, yeah, so what I do is I'm going to put the, I'm just going to snip, I think I'm going to snip the switch off. I'm just going to get my soldering iron out, and I'm going to be basically just putting in a new unit the same way as you see it here, and it's going to go into that one area over here. I'm sorry, over there, and we'll get it together. That should work. All right. Yeah, some of you guys are maybe old school. So I had this lying around at I have other stuff in another location for electronics, but out in the garage here, I only have this, but that's old school. That used to be Radio Shack's brand name, well, one of their brand names, Archer. So if you're an old guy like me, you'll recognize Archer being a Radio Shack brand and hanging out at the store and getting all kinds of discrete components or whatever. Fun stuff. Anyway, so we're going to heat this up so we get the solder melted here. Okay, it's one. I'll do this with my left hand here, but two. All right, so next thing we're going to do is get the new one, which I've already pre-stripped. And we're going to put, I think we'll do, try to have a little tin here, tin the end just a little bit, make sure we get a good bond. And we do the other side too while we're at it. Whew, heat goes right through that wire. All right, so what we're going to do is we're going to straighten this out a little bit. Yeah, you want to make sure that you know, we have enough where this thing is going here. We're going to go to the bottom. So this one, the short one, will go on the bottom one here, so it's a little closer to the valve. I had to kind of figure this out because, you know, these things again are not set up for necessarily what we're doing here. They're meant for these deck heaters or whatever, so they have a little bit different arrangement inside. All right, so that's all attached. We're gonna now just kind of get this configured so that we can get this attached. Let me go on the outside. I think I figured this out, that we had to go outside first and then get this guy. Maybe we do it on the inside, I can't remember. And we do it on the outside, it's fine. Hot, hot, hot. So that this is going to thread into the back of that aluminum housing on the control valve. And they got this like panel here, which is a pain in the ass because you really can't get your fingers around it too easily. But the wrench fits in there good. So we'll get that cranked up. Again, replacing both of these is really, I think, a must-do scenario because these Thermopiles don't last, you know, indefinitely. They do have issues occasionally, and you know, with the amount of hours that this thing is running, you don't want to be too crazy about not doing it, only because you're just going to be back into this thing again once you get it all together. Oh, now it doesn't work anymore. So now we get to put this sucker in here. Now the thing that you got to pay attention to is the depth. We want to make sure that we go to the same depth, and they're pretty close to one another. There's a little difference in diameter here, you know, a little stop. That's not going to be helpful, only because it's a little bit different. You know, they have a groove in here, which we don't need, but you want to make sure that the depth is far enough in, but it's not too far. So we push it in, and it's typically you know, on this particular one, you got a groove here. It pretty much stops just as you know, get to the groove. Okay, so once that's in there like that, then you take, again, do not over tighten this. You just snug it down to give it a tug back. Everything's good. Now you're good. So the thing that you want to do is you want to be careful bending all this wire around. Okay, make sure it's not touching anything in there. You can just float through. We don't need to tie wrap anything, but you're just getting it so that, you know, the wire management is good. And then this sucker can go right where it was. It's in the slot down there, and then this is going to go to the cover. All right, so the only thing we have left is the sintered filter. That's going to go on to our, you know, into our hole here. Challenge with this guy, and you know, it's got to go hole facing towards the tube, towards the hose. Okay, it's kind of hard to do this, you know, when you're sitting here underneath and dropping it into this hole. So I like to just see if I can get this standing up in the hole with my finger or whatever, and there you go. And then we screw this in, and you want to make sure that you just be really careful to make sure you get it into the hole that's in the valve, because if you are cockeyed and it's going to hit the edge of the hole, you're going to damage that little sintered thing. So make sure when you do this that the hose, the regulator, is facing towards the inside of, I should say, towards that direction. The same direction as where the nozzle is going to go, because that's the way you're going to connect to your tank. So you're going to get your adjustable, and then you're going to snug that fitting down. Again, do not over tighten it. It's just a compression fitting. There's no need to over tighten anything, but you don't want to leave it loose. All right, so that's that guy. That's that guy. So pretty much at this point, what I would be doing, and what I'm going to do, is get a propane tank, stand it up here near the bench, and basically light this thing up. It started up like it was first time this season, and see how it runs. And everything should be working fine at the end of the day. I think it will be. The other thing you want to get is some soapy water. Put it over these fittings here and even on the bottom here, just to make sure you don't have any gas leaking out. I just get some dishwashing detergent and put it in a little bin or whatever, and just put a little dab on with my finger. You don't have to go crazy. Again, all over the valve. Just make sure there's no leaks in the valves or anything like that. It should work just fine after all this. And I will go get the gas and see where it goes from here. Okay, I got the tank hooked up here, and I'm gonna be lighting her up. So I got the valve turned on. I did do a little bit of check a little while ago just to make sure we have no gas bubbles coming out. But let's light her up for the first time. All right, so what we're gonna do is we got the gas valve. We're gonna hold this button down. You can hear it popping. Might take a little longer because there's no gas in the valve and everything, so it has to flow up, and then you notice you'll notice a change in the tone. It's kind of the tone is muffled a little bit by the housing. I just usually hold on to it for a good 15-20 seconds, and then I'll release the igniter. You can hear it getting louder. There it goes. Just the sound gets lower, and now we'll hold on to the button a little longer. We got to make sure that temperature gauge starts to go up, and when it does, it reaches that green zone, then this whole thing should start up, no problem. But again, what am I doing now? I'm holding down this pilot valve, so that's compressing the little plunger on the coil, and as this thing heats up, yeah, it's getting warm. You can feel it on the side there. It's going to get warmer and warmer. This is going to create its own electricity and allow this valve to stay open. Now I'm just going to look at this thing here. Well, we're almost there. Smell of new parts. You can smell a little smell of something burning a little bit. Nothing major, but we're pretty close to the green line there. I'll hold it another 10 seconds. All right, we're in the green. We'll let go. And as this thing begins to warm up, it's going to start building electricity to run the fan and the light, which is not connected right now, but it's still going. I can hear it. Get you a little closer. You can see the valve, starting to get into the green. And this high-pitched whine you can hear. I don't know if it picks it up on the sound of the phone, but it's a very high-pitched whine, and I've seen that in all of my units. It's when there's just barely enough electricity generated by the Peltier devices to generate the power needed to turn the fan. But the fan will turn on its own. I could push it right now and probably start it, but I'm not gonna. See what happens here. Still getting hot. I can push it, see? And it'll kick right on. Air is being sucked down this way, and so as this fan operates, as it gets warmer and warmer, the fan will spin faster and faster until it's maximum RPM. And yeah, keep that running. So let's see how this thing's going to go. So I've got a little thermometer here, and we can point it at where the thermopile is, and we're at 113 on top of the 122 there. It's going up. So what the system has to do, it has to heat this whole mass of aluminum gets to be warm, especially the combustion side. That side over there, it gets to be the warmest. This whole thing Over here stays relatively cool to the touch. I mean, right now it's pretty much like room temperature, like, you know, 78, 79 degrees. So it'd take a while, but you know, the closer you get over to where the flames are occurring, which is right in this area, you know, down on this box here, up to 140, 154. And you can see the temperature gauge keeps climbing. And this is, like, remember I told you before, this is the exhaust, right? This is pretty cool, but as you get closer to where it comes out of the top here, you're going to see it climbing up. Even the output there, 131. It's hard to do this with two hands here. Right by the igniter there, it gets pretty warm. Yeah, so this thing, you know, we'll keep it running for a little bit. So far, so good. Yeah, we're right around 165 right now in the corner here. So right now this operation tells me that the pilot is staying lit, or I should say the flame is staying lit, you know, in the nozzle here, which means that the thermopile is generating the right amount of electricity to hold that little valve solenoid open. And on top of that, the thermopiles, the pelletieres that are in between the combustion chamber and the housing here are functioning the way they should, because now the fan's being driven. The fan has, you know, 0.3 amps, I think is what I mentioned in the very beginning of the video. But you can hear that the fan is running a lot faster now. This thing's very close to its operating temperature. I think I remember telling you before it was around 170, 175. What are we at now? Oh, we're 183, 180. And that's at the top of the housing. That's pretty much, this is like the warmest area. Don't forget on the outside, I don't measure on the outside here because you've got that little thermal gasket between, so you're not going to get the temperature reading. You got to measure on this side of the cover only because there's no thermal gasketing in that area. So I'm going to let this run for a little while. You want to do this, if you're going to do this in your garage, try not to do it with like the doors and windows and everything closed, because there is CO2 coming out of this whole thing. Okay, there's CO2 coming out of the bottom of the unit, and it's spilling everywhere. So you know you don't want to have CO2 poisoning and pass out in your enclosed room where you got this running. But you certainly want to make sure that you got ventilation. You know, I've got a door, and this is a pretty big room for the time that I'm going to keep this running. But this will keep going. I'll keep this going for about another 10, 15 minutes just to verify the operation, and then I'll turn off the gas at the tank and put the rest of it together. What I like to do is when I put the housing back on the top here and I plug everything in and screw it all down with the 3 screws to get it back completely together, I'm going to hook it up again and restart it. I want to make sure the lights are going to work. I want to make sure I get another perfect start first time. And by the way, when I started this for the first time, that was truly the first time. I didn't start it offline, off camera first. Being totally honest with with the YouTube group here. You know, I wanted to see for sure if everything was going to work the way I did it. So this is a one-take job, and it's simple. This whole thing is simple. It's really not complicated. And, you know, if you know what you're doing, and hopefully I explained it for you guys, you'll get these units back and running no time with minimal expense. And I'm going to include some information on the parts that I purchased. I didn't spend, I think it was probably, I'm going to guess, under $25 or $30 total on all the parts. Now, obviously the traps and the sticky trap and the lures, you're going to pay a lot more money for those anyway. But these things, brand new, are, you know, $400, $500, $600, $700, depending on where you go. Brand new. And if you can keep these things running another season or 2 or 5 or 10 with some of the techniques and the information that I'm able to give to you guys, you know, please like my channel here. I'm going to be building more on fixes like this, and maybe more in-depth explanations about how these types of things work. So maybe you get a little education too. And great. Thanks for coming along for the journey. Good luck. And remember, if you guys attempt this, you're on your own. I'm only showing you what I did, and I didn't blow up. I don't think you will either if you're just careful.